Atoms are incredibly small, almost ridiculously so. They are the fundamental building blocks of everything around us. To put it in perspective, a single human hair is as thick as about 500,000 carbon atoms stacked on top of each other. Look at your fist. It contains trillions and trillions of atoms, far more than you can ever imagine. If one atom in your fist were as big as a marble, your entire fist would then be about the size of Earth. Still hard to imagine such scales? Let's try a different approach to grasp these immense differences. Consider your little finger. Imagine its tip is now as large as the room you are currently sitting in. Now, fill this entire room with grains of rice. Each single grain of rice represents one cell from your fingertip. Zooming in further, if one cell is the size of your room, then one grain of rice within it would represent a protein. Next, let's fill all the empty spaces between these rice grains with even finer grains of sand. This progression illustrates the incredible scale, from your finger to a room, then to cells, proteins, and finally, atoms. So, what exactly is an atom made of? Let's simplify its structure to better understand its components. For simplicity, let's visualize atoms like this for a moment, making it easier to grasp their basic structure. An atom fundamentally consists of three elementary particles: protons, neutrons, and electrons. Protons and neutrons bind tightly together, forming the dense central core of the atom. This core is held together by the strong interaction, one of the four fundamental forces governing the universe. Neutrons, in turn, are made from even smaller particles called quarks, which are held together by gluons. The exact size of quarks remained a mystery. Nobody knows precisely how small they truly are. Scientists theorize that quarks might literally be points, existing in zero dimensions, much like a point in geometry. We suspect that quarks and electrons are the most fundamental components of all matter in the universe. Electrons, on the other hand, orbit the atom's core, moving at incredible speeds. They travel at an astonishing speed of about 2,200 kilometers per second, a truly mind-boggling velocity. This speed is fast enough to circle the Earth in just over 18 seconds. Electrons are considered fundamental particles. Remarkably, over 99.999999% of an atom's volume is actually empty space. However, this emptiness is not truly empty. It's filled with quantum fluctuations, fields with potential energy. These quantum fields spontaneously build and dissolve, constantly interacting and influencing charged particles. So, how much space do the atom's core and electrons actually fill within this vast, empty volume? If you were to remove all the empty space from the Empire State Building, its remaining matter would shrink to the size of a single rice corn. Similarly, if all the empty space were removed, all the atoms of humanity would fit into a single teaspoon.
Such extreme densities actually exist in the universe. For example, in objects known as neutron stars.
In a neutron star, the mass of 3 suns is compacted into an object only a few kilometers wide, incredibly dense. By the way, atoms don't actually look like the simplified model we've been using. So, what do they truly look like? Well, they look more like these hydrogen electron orbitals. Electrons behave as both a wave function and a particle. We can calculate the probability of where an electron might be at any given moment, forming these clouds of probability called orbitals. These orbitals represent where electrons are likely to be with a 95% certainty. The probability approaches zero further from the core.
However, the probability never truly reaches zero. In theory, an electron could even be on the other side of the universe.
Yo, electron, come home!
You're not my real mom.
These fundamental, strange things make up all the matter in the universe, forming countless elements and substances. Thank you for watching Scientific Summary. Subscribe for more mind-boggling science and discoveries about our strange world.